Welcome back. Today we'll talk about sustained yield. Now we have to understand what is sustained yield. If we get yield from any forest continuously on a regular basis every year, and we don't take care how much we are extracting from that forest, the yield is certainly going to go down in the coming years. So we need to maintain sustained yield. That is, the amount we are taking, it should balance the amount that is being produced by the forest. So how we can define sustained yield? The material that a forest can yield annually or periodically in perpetuity, means for n number of years to come. And it is also defined by Osmaston as the regular continuous supply of desired produce to the full capacity of the forest. We can also understand this sustained yield as the yield of timber or other forest produce from a forest which is managed in such a way as to permit the removal of approximately equal volume or quantity of timber or other forest produce annually or periodically, but in perpetuity. So we have to maintain this yield continuously for perpetuity. Now how we can maintain it, you can see in regular forests. This is the example how we take the yield. This is the original stand, and in the initially we give 20 to 40% cut, means we remove 20 to 40% of the trees, and in the second cut, after a period of 10 years, the trees are reduced to this much, and this is the removal of or final cut, which can be after a period of 5 to 10 years from the second cut. This is the total clearance of the crop. Now under uniform shelter wood system, how we maintain it? We have, you can say, preparatory cut. We give preparatory cut for regeneration to come up, and in next we have seed cut. We again fell some of the trees, creating some gaps. You can see here some gaps are created for the regeneration, and finally we give a removal cut, removing the mature trees once regeneration is established. Only a few number of trees are left, so that the regeneration that has come up, you can see here the regeneration has come up, to protect them from frost or high amount of insulation for their protection. Now we have to understand this diagram. This is the age in years. In this diagram you can see in hectares, and age in hectare, each coop is of 1 hectare. So we are maintaining an area of 10 hectare, 1 hectare to each coop, for a rotation of 1 to 10 years. This, you have to understand, this is the crop volume that has been produced in the first year after planting or after sowing the seeds. Now in the second year, the same crop adds one more I, small I, as increment, and the total volume becomes 2I. In the third year, the 2I, one more I, small I, is added to this, and it becomes 3I. Likewise in the fourth year, some more increment is added, so it becomes 4I. And in the final year, the same coop which was I in the first year becomes 10I in the final year. Now the harvesting may take place. We are maintaining 10 coops, and at the 10th year we have coop number 10, which has the highest volume, 10I, and 9th year coop has 9I, 8th year coop has 8I. We have to understand we can only remove as harvest the crop which is mature, and it is clear and obvious from this diagram that 10th year coop is ready to harvest. So in the 10th year we harvest this I into 10 is equal to 10I, which will be our yield in that particular year. And next year it will again, after harvesting, this will again move to this scoop as it becomes I, or 0 in the initially just after felling, and I at the end of the first year. And this 9I will move to 10I, putting an increment of I, and 8I will move to 9I, 7I will move to 8I. Thus maintaining a regular series of age gradations, so that we can take yield every year sustainably without endangering the future yield. I hope you got this